Hi, my name is Dror Ayalon, and I would love to talk today about creative music applications in Python, but I would really love to expand the topic a little bit and to talk more about creative coding in general, because creative coding really loves Python. And if you think about it, you can go on GitHub today and find implementations of any cutting-edge research you can think of, from audio analysis, NLP, NLU, IoT projects, deep learning for sure, statistical models, anything you can think of. And this toolkit really makes us, the Python dev community, possibly the greatest and the biggest creative community in the world. So just let me give you a brief about myself. That's a little bit small, but I hope you can read it. I studied for my BA Communications and Human-Computer Interactions. Then post my graduation, I moved to become a product manager at Viber. The company was acquired, and I moved on to be the VP of product management for another Israeli startup. And throughout this time, I realized that what I really love to do is to build things. I love to manage the development process, but building things was really a new passion to me. So I started learning how to code and enrolled in NYU, where I studied mostly machine learning, music information retrieval, and started to build applications in this intersection. A few months ago, I graduated, and now I work for the Google Creative Lab as a creative technologist and building full stack applications using machine learning and music. So on today's talk, I would love to present to you Soundscape, a project that I worked on and published recently, a music project that I hope will be a good case study for everything that I mentioned before. I would love to talk about experimentation and prototyping and why is this such a crucial step in building an application and developing your skills. I would love to mention a bunch of projects and packages that I used for my projects and hopefully will be useful for you guys. And I'll try to make the argument that creative coding equals self-development. So Soundscape. Soundscape is an online platform that syncs music loops recorded by different users. So this is my looper pedal. I'm a guitar player myself, a bad one, but a guitar player still. And this is by far my favorite toy. I play many hours using this toy. And at some point, I realized that looping is magical. There's something fantastic about something that happens repeatedly, over and over again. It's some sort of a meditation for me. And about a year ago, I decided that what I want to do is to build an automatic looper, which means that I'll be able to play freely, and there will be a software somewhere that will segment my recordings, okay, and will find repetitions in my recording automatically in real time. So I started to prototype, and I want to show you just a quick thing. Oh, there it is. So this is a simple file, a simple Python file, and I want to show two things. One is that whenever I start a music experiment, NumPy, SciPy, Librosa, and PyAudio is probably my default pack. Okay, so I import them automatically. And there's like a bunch of stuff going on, and I'm sorry that the code is so messy. It wasn't, the purpose of it wasn't to present it for anyone. But I want to show you this getLoopsIndexes function that its purpose is to go over an array of audio, a time series as we call it, and to find these segments, okay, and to speed back a list of the indexes where the segment starts and ends. So what I'm doing here is that I'm using a global audio buffer that keeps on growing as I record, and I'm using a bunch of out-of-the-shelf, let me just make it a little smaller. I'm using a bunch of out-of-the-shelf functions to analyze my recording. So Librosa gives me the ability to analyze onsets, sudden changes in the recording that we preserve as beats usually. Okay, so it's a rhythmic feature. And then I'm taking these rhythmic features and I'm passing them through, again, an out-of-the-shelf autocorrelation function. And for those who are not familiar with autocorrelation functions, this is a function that will take two lists, okay, two arrays, we'll pass them one on top of the other. So if it's an autocorrelation or it is doing it on the same list. So I'm taking one list and passing it over itself. And when I get segments that are similar, I'm getting high value. Okay, and when the segments are not similar, I'm getting low value. So, so this is just a way to do it in terms of the rhythm, and I'm, pipelining this data and speeding back this array. There's another way. Hey, this is I got them. But there's another way to look at the same problem from a spectral way. Okay, we can say, okay, beats are not necessarily the best way to segment an audio file. So again, just using Librosa, I'm getting this fantastic chromogram which describes the frequencies in the recording. Okay, so and you can see, your eyes can see that there are some repetitions here, right? So I'm segmenting the audio. Okay, so now I know how to chunk the audio correctly, but instead of a list, now I have a matrix that is filled with data and is super large. And what I need to do is to reduce the data to process it in real time, because there's no way I can process this amount of data in real time. There's just too much. So the trick I'm using here is the FFT convolve trick. It's a simple convolution, the same convolution trick you hear from neural networks and stuff. What I'm basically doing is I'm getting the essence. Okay, I'm getting what is the actual difference between each one of these segments, and I'm reducing the data to make it something that I can work with in real time. So combining these two methods, I built this simple terminal app that let me just play freely, and when I repeat something twice, it prints a loop. Yeah, it's yeah. So it was really hard to make it work in real time, but sometimes it did. And this is an example for when it did. There is something we'll repeat here in a second. All right, so the script understands the segments and knows how to split, stitch, play. Nice. So that was the first prototype. I thought that I'll make this list at the top here with all the packages that I'm mentioning, so you'll have it at the top there. So this prototype was awesome. I learned a lot. I learned how to process data, audio data in real time. I learned how to reduce the data. I learned how to use this sliding window trick of the autocorrelation. I also learned that automatic looping is not that interesting, so I moved on to the second prototype, which now, since I knew that I know how to identify loops, okay, and they're not that important or interesting, I added this option, this fourth option here, to get another layer, and which means that I thought, hey, if I know how to identify loops, and I know how to identify my loops, maybe I can identify other people's loops, and maybe I can mix them together. So maybe I can find, people who play weird music the same way that I'm playing, or someone who's like as bad as me, but at least, I know there's echo somewhere. So let me show you the code first before I show you the examples, because there's something really interesting there. Okay, so here's that. Oh yeah, here's the menu that that you see before. But okay, so you started a recording and then you want to stop a recording. So when you stop a recording, what I actually wanted to show you, okay, here it is this analyze file function. This analyze file function is, again, pretty simple at this stage. What I'm trying to do on the prototyping stage is to take what I can out of the box and not to rewrite functions or not to find my own way to implement things. So what I'm doing is that I'm creating this dictionary with all the data that I can find using Librosa and maybe other tools from the onsets that I talked about earlier, from beat tracking, which is just a different way to identify beats, to zero crossing, which is the measurement that will tell me how noisy the recording is, to the chroma here. So now I have spectral features, okay? And now you can start to think, okay, what is the most dominant note here? Or what are the intervals? Is it a major recording or a minor recording? Stuff like that. And I'm creating this dictionary. What I do next is when we go again to this get another layer option, Again, just a dirty, dirty script. Don't write code like that ever. But what I'm doing is that I'm trying to do the basic stuff. Like, okay, so since I have this data now, I can load it with pandas, and I could try to find recordings that have similar tempo, maybe, 5% less, 5% more in the BPM, and then I'm starting to filter things down. So I'm filtering down based on noisiness, because maybe I get things that have the same BPM, but one of them is super noisy and one of them is super quiet, so I won't be able to hear them after the mix. I'm not doing any balancing at this point. And now I'm filtering things based on harmonic. Okay, so I'm checking if the intervals are perfect intervals. Okay, so if the mix will be harmonic. And this filtering method wasn't that good because in most cases I didn't have any files left and I didn't have a lot of files to begin with, but sometimes it did work. And this was the first time it did work. So this is the initial recording. Very simple riff. Okay? And now I asked my terminal application to add another layer so it sounds like that. Really good. At least not bad. So, I got hungry. I asked to add another one. Now it sounds like that. Nice. But it starts to feel like maybe the rhythmic features are, driving all the experiment, and then I got my response. Nice, right? Okay, so that was fun. Okay, so I'm adding to the list pandas, which is surprisingly useful for creative applications. I'll take questions at the end if that's okay. Pandas, PyDub, an amazing audio package that allows you to convert files from different formats to process audio. I love it. And FFmpeg, which is a must-have on any audio application. So at this point, I started to know what I really want to build. I started to understand what Soundscape will become. I know that that I want to record a loop. Okay, this is like looping is the essence of what I'm trying to build here. And I know that I want to find loops that were recorded by other people and could perfectly sync, right? So I want to be able to connect people through music. No matter what you're playing, no matter where you are, there's someone who's playing something that could sync with what you're playing. And I wanted to be able to mix them together, but most importantly, I wanted to do it repeatedly. So I didn't want it to be a terminal app. Okay, so for Python people, what I'm saying is that I want to build a web application in Django. Okay, so this is me making the Django thing happen and playing while doing it. It was a lot of fun. We'll have a quick look at the code. Here's Soundscape. So as you might expect, there's this views file that has all the routes. Okay, so from user page and loop page and the ability to fork a loop, so you can use someone else's loops. That's fine. Or it's just normal API, new loop. Okay, but the most interesting things are this analyzer py file. So as you can see, in this analyzer file, here is the same object, right? The same pattern that I used on my prototype became useful when I created the final application. But now I'm using a package called MadMom, which is the cutting edge in audio analysis and processing. And it gives me an array of RNN models to get the best beats prediction you can find anywhere. So yeah, I'm doing things a little bit differently here, but the method is pretty much the same. There's a peak picking function that I added here on my implementation, but overall it's all the same. And if we look at the matchmaker.py file, which is in charge of, okay, so we analyzed a bunch of files, but now we need to find matches between these files. So what I'm doing here is, again, the same trick. I'm getting all the sounds, okay, and starting to filter them down. At this point, after experimentation, I realized that filtering down based on harmony first is a better idea. So I'm doing that. Then I'm filtering based on the beats. And then something that is dramatically, I'm filtering based on the noisiness again, but even though I'm doing balancing. But there's this find best sync point function here. And what this function does is instead of finding the file that has the best sync potential, I want to find the best syncing point among all files. So as you probably remember from the first prototype, the one that I thought is not very interesting, I'm using the same trick with the sliding window. I'm using one track as a slider, and I'm passing it over every possible sync, every possible recording, to get not just the best file to sync, but the best place to sync this file with the other file. Okay, so this method, and it's pretty complex, complex implementation. But the idea was that the prototype, the first prototype that I thought is not really interesting, became super useful at the end product. Okay, so I'm going to add Django and MadMom and audio read and sound file to this list. And audio read and sound file was super useful in converting binary audio to formats that we can actually use to get audio over HTTP, stuff like that. And also, it was super fun to develop the application. This is me strumming on my guitar just to get some debug sound. But since I'm not a musician, I asked to get tons of recordings from my friends and just to sync my stuff with stuff that my friends played. It was kind of awesome. And when Soundscape was ready, I decided to create this video and to let other people know about it. So this is the Soundscape instruction manual, if you like. You can use any device to connect it, to play, record. You can record as many layers as you want, like a normal looper. Then if you decide to keep your recording, you can find something that hopefully syncs what you played. Then you can say to other people, hey, thank you for letting me use So that was nice. And then Soundscape was out, and I waited at home to see what people would do with it. Because, I'm not, you don't know what will happen. So some people actually, didn't even pay attention to connect any instrument, and they just use their mouth like that. That was awesome. Some other people really created more complex rhythms, like this one. And when I saw these kind of tweets, I knew that Soundscape can actually connect people for music, and that was awesome. And then I realized that what I really want to do is not only to connect musicians, but also to connect with the dev community. So I thought, what's the next step here? I mean, should I just take this huge Django project and put it on GitHub, and hopefully someone will find what they want in it? And so I decided that what I want to do is to take the core component that I used in Soundscape and to create packages from them so people can use them as building blocks for their own projects. So I created Audio Owl and Mixing Bear. And Audio Owl and Mixing Bear are awesome. People started to use them, and you can see that with just a single line of code, you give it an audio file, and you get back all the audio, all the analysis that I got on Soundscape. And Mixing Bear is actually using Audio Owl to get two audio files and to mix them perfectly the way that I'm doing on Soundscape. So now you can use it for your projects. But these are not the only projects you can use. There's Google's Magenta project, which is awesome and simple, easy to use with a bunch of pre-trained models that you can use. If you don't like MIDI that Magenta is built around, you can use WaveGAN to generate your own raw audio. Or if you're a text person, so textgenrnn is the package for you. There's a bunch of other Python packages that you can use for your own creative applications. And I'm happy that audio and mixing bar are now part of this list. But I think you can start to see the pattern here that building something is super awesome, but also it makes you learn a lot of things. And when you learn stuff, it's awesome to think how you can pack it. And if you pack it correctly, you can teach other people about it. And if you teach other people, they might start using it. And our community will grow. And then more people will build stuff. And then we learn more. And then we pack more. And then we teach and grow and build. And learn and pack and teach and grow and build. You get it, right? All right. Thank you so much for your time. Have time for questions?
We have time for like 2 questions.
I'm here anyway, so yeah. Yeah.
So when you initially got started, how many audio files were you trying to match up at the very beginning?
How many audio files I had?
Yeah.
I asked people just to give me, the audio files that they have. So initially I started with like 10 files, and then, you put it somewhere, you tell friends about it. Some people started to donate more and more and more files. I had like 100, and maybe then at best 1,000. That's it. Yeah. Yeah.
Have you looked at trying to do like pitch shifting?
Yeah, I thought about pitch shifting and even time stretching and stuff like that. But the idea behind Soundscape was that the raw audio is, is sacred, and I'm not touching it. What you recorded is what I'll save and what I'll offer other people to use. I'm not manipulating the audio. But it was a decision, that I made as a developer. There are many other viable decisions to make. Yeah. Any more questions? Yeah.
How can someone who is not a musician or doesn't play an instrument at all and isn't creative music theory capable of trying to pitch in or use the stuff that you build?
So the question is how people without any knowledge of music can use Soundscape?
Yeah.
So, Soundscape you can plug in any instrument, or you can use, singing or whatever. But, Soundscape won't ask you what you know about music or not. It will just try to analyze, what notes you hitting or what is the rhythm of what what you're recording. So I guess it's non-judgmental in any way. Yeah. Yeah.
At this point, how many files do you have, and how does the scalability of your website now?
Well, coming from long history of startups, I decided that Soundscape was not meant to be scaled. I mean, secretly, I built it to scale, but I didn't market it to scale. So I don't know, there's like half of your questions I don't know how to answer. But how many files I have? I think currently there's like about 15,000 files, which means that there are about 80,000 mixes. Okay, using because you can start the Soundscape experience even without recording anything. You can just ask the system to give you a random loop and to start from there. So basically, you can just stack up loops by other people without contributing anything of your own. Yeah. Questions? Thank you so much for coming, guys.